Alright, ladies and gentlemen, welcome to ComSci Connection. Today we're going to talk about polymorphism. Now, I'm going to get the biggest question out of the way first. What is the difference between inheritance and polymorphism? I feel like a lot of people get confused. I've been asked this question a lot of times. So, as a quick explanation, the unofficial, non-book answer, to hopefully just clear the air, is that inheritance is basically what you inherit from classes that are above you. Just like genes, for example, you inherit the genes from your parents, right? Well, inheritance would be what properties a class inherits from a class above it in a hierarchy. So as you can see, I've drawn a short hierarchy here. At the top, I've got an interface called payment. It basically, let's say it defines a method called, just pay. This is called pay. Now, we know that anything that is derived from the payment interface must implement the pay method. That's basically a rule that the interface has defined. So we know that, therefore, cash, check, and charges derived class credit and debit, and credits derived class platinum must all implement this pay method. There might be more that these things can do, and there is, but we know at the very core that all of them can pay, and that's why they're payments. So that's inheritance. Cash, check, and charge all derive the properties of the pay interface, pay, the method pay. Polymorphism describes the ability for these objects to interact with each other and basically, well, that's not a very good answer. Not interact with each other, but to change their behaviors based on each other. So a better explanation would be more like an example. So a payment could be cash, right? And then maybe when you pay, you give somebody change. And that would be a behavior of the pay method in cash. But with a check, let's say that you, for the purposes of this argument, let's just say that you can't ever write a check for over. Then all you do is you just take the check, and maybe the cashier has to validate your driver's license or something like that, or your address. But that's behavior in the check class. And then in the charge class, we might just run the card, and it might, depending on whether it's credit or debit, have different behaviors. Like a debit card, you might have to enter your PIN, but in the end, it's still going to pay the same way. Credit card, you don't have to enter a PIN, but you might have different behaviors there based on the card itself and the object. So the ability for my payment object to change between cash, check, or charge, or charge, credit, or debit, is really what polymorphism is. So as an example, let's say that I did something like, let's start out with something simple. So I do something, okay, I've written up here can do equals will do to describe that first so you won't get confused. If you haven't seen my interfaces video, this is basically what your compiler understands and what objects, how they behave when you're actually running a program. So something like, as an example, string s equals new string. The compiler stores an object that's created somewhere else, and it stores that in memory as a string. So you got a memory pool here, and we'll just say that there's this hunk of memory that's been reserved, and the compiler is told that it's a string object, and it's told that it's going to refer to it as s. So anytime I invoke s, the compiler understands that this object s has the properties of a string. And what it actually does when it creates this string object is it creates it somewhere out here in La La Land in this big magic pile of memory, and it calls it a string, and it gives it all these string properties that a string has and all these methods and whatnot, and then it just points to it, or it references it. References it. So we know that when we refer to s, we're referring to a string object. So when we say something like s dot, care at 5, it refers to this object s by referring to it via the reference. Then the string object itself actually carries out the execution. So that's, on the left side, basically what the compiler knows that this object S can do. Well, it can do things that a string can do, because I said that it was a string. What it actually will do when I call something like the method char at 5 doesn't really matter to the compiler at all. It will only, at runtime, when the code is actually being executed, it's going to actually refer to the string class and carry out the instructions at that point. Prior to that point, it doesn't matter what object it actually is. And that is the core of polymorphism. So if I have this fancy payment interface, I can say payment P equals, and we're just going to call it a new cache. So now when I say P.pay, and we'll say 200, if my, if my bill is 150, then I get 50 in return. So it might return 50 to me. Then maybe that's something that we'll have this method do, just return an int, whatever. So $50 comes back in returned value, returned money. But if I then, or let's say I didn't do that, I change it and I say P equals new check. Then I do pay, or P.pay 200. Then the compiler is still happy with that because it knows, just like it did before, that a P is a payment, so therefore you can pay. So a pay method is valid for P, so it's perfectly happy. But at runtime, before I wrote new check, or let's just say if I just stuck that line back up there, it's going to refer to the cache class in order to execute pay. But if I write that line here instead, it's going to refer to the check class because it was a cache object and now it's a check object. So if I refer back to my fancy memory diagram, it basically looks like this. There's something in here, it's called a payment. It recognizes that it has a pay method, and out here somewhere it had this cache object which existed for a short period, and it pointed to that, and then I created a new one called a check, and it suddenly didn't point to this anymore. This was X'd out, and it suddenly now points to this. So when I refer to the P object here, when I say P.pay when it was cache, it referred to that object. And when I say P.pay after I made it a check, it's going to refer to this object. And in fact, since nothing else references this cache object, it'll get magically cleaned up by everyone's favorite garbage collector. So let's stop drawing primitive memory diagrams and stop dropping the eraser. Oh, this eraser's much nicer. That was a win. All right, so we have more chalk. So what does this mean? Why am I talking about this? So let's say that I didn't have this as a cache object. Let's say I made, actually let's do this. Better idea. Let's do cache C equals new cache. That's valid, right? I mean, that shouldn't be confusing in any way. It's not a trick at all. It's just a cache object. Now that's going to behave. Well, let's say that cache doesn't have any other methods besides just pay. So cache is going to behave the exact same way, and the compiler would still understand that it's a cache, so it inherited all of the methods of its superclass, which in this case is an interface payment. So the compiler still knows that it has a pay method, so I can still do C.pay 200, and it's perfectly happy. And that'll, in fact, behave the exact same way as it did before. But now, let's say that right below that, I do payment P equals C. Is that valid? Well, of course it is, because in my memory diagram, you can imagine that there's this cache object that exists out there in Wonderland, and this thing pointing to it says, "Yep, there it is. It's right there. It's a cache. Yep, right there. Go if you want that. If you ever call and see, I'm gonna point over there." And that's my job, so that's all I'm gonna do. And then this other guy comes along, and he's like, "Well, I'm a payment, and okay, you want me to point to that same thing? All right, well, I can do that." And he'll just stand there and point to the same thing. They have the same behaviors, and the object is still the cache. And in fact, if I went in and did something crazy, like changed this, I modify the actual object itself. I don't mean like make C equals a new object, but modify the cache object itself somehow, then that property is reflected on payment P as well, because it's pointing to the same exact object. So if, let's say that cache had like a certain denomination of bills or something like that you had, I could go in there and change those bills, and then both P and C are going to recognize that change because they're both pointing to the same object. So that's perfectly valid. Now, in addition, I could see what else. So basically it casts this cache object up to a payment object, but because it's still a cache object, what it actually points to, it will have the exact same behavior. So C.pay 200 and P.pay 200 are going to do the exact same thing. Even though this is a payment object, P, and this is a cache object, C, they're both the same cache object. And even if they weren't, even if payment P equals a new cache, and these were two different cache objects, the method pay still refers to the class cache to execute the function, and therefore has the same behavior. Now, let's try something different. So, you know I can do payment P equals new cache. You saw that I could do, so you would assume also that I could do payment P equals new check, new charge, and that's true, you can. But let's say I have check. What's going to happen here? This is the kind of stuff that I wish there was a way for us to have dialogue over the internet like this, because this is where I want to start picking your brain. But it's going to get more challenging, so for now let's just keep it simple, and I'll just tell you that this will not work. And there's three options that we're going to refer to when we say something either works or doesn't. It either works, it has a compiler problem, or it has a runtime problem. This is a compiler problem. The compiler will actually underline this because it recognizes that a cache is not a check, right? See, they're horizontal to each other. So a cache is not a check, and a check is not a cache. And also, cache is not a charge. Just like credit is not a debit, and debit is not a credit. But all of credit and debit are both a charge. And charge, check, and cache are both a payment, or all three of them are a payment. So this is what we call an is relationship. A credit and a debit, like a debit is a charge, a credit is a charge, and a charge is a payment. So by the transitive property, a debit is a payment. Same with a check is a payment, a cache is a payment, but a check is not a cache, and a cache is not a check. So this is just like saying string S equals new dog. A dog's not a string, you can't do that. So the compiler is going to underline that, saying, well, dude, you said that this was going to have like properties of a check, and like there's supposed to be a pay method, but this has got that, but it's not a check, so I don't think I can do that. And it's going to complain, and that's what it should do. But I can do this, of course, new check, right? And there's no problem with that. Then I can change check here to payment or whatever. So what happens when I'm going to make this more fun. So what happens when I do cache C equals new cache, and this isn't going to be that tricky, and then I do check C2 equals C. Runtime error or compiler error? Well, runtime error, or no, sorry, compiler error still, because it knows that this is a cache object because you told it on the left side that it was a cache object. Even though it actually is a cache, then that doesn't matter. But it is, you told it was a cache, and you told C2 it was a check. And so the compiler is able to check, and that's a bad word for this example, but the compiler is able to compare a cache against a check and determine that they're not the same thing, because this is not this. But you saw the but coming, right? And you knew there was going to be a but to this. This is where it gets confusing. So payment C equals new cache. And then check equals C. Well, a check is a payment, but, so this is valid, this code, payment C equals new cache. We know that that's valid because cache is a payment. But a cache is not a check. But the compiler doesn't know that it's cache. It only knows it's a payment. So when you try to say check equals some kind of a payment, your compiler doesn't know that that's not valid. This is actually going to cast down. It's going to cast your payment object, C, down to a check. So in other words, this will have the same exact behavior as manually casting it, saying check. And this is actually what the compiler does. It will actually cast this down to a check. And so check. So cast C to a check and then assign it to a check. Well, this will actually compile, because the compiler doesn't know that it's a cache. It doesn't know that this is a sideways relationship. It knows that you said this was a payment, and a check is a payment, so all it knows is, by all intents and purposes, I think this is okay. But when you actually run this code, you're going to get a runtime error. It's going to crash, and it's going to say, well, dude, I can't do that because a check is not a cache, and so therefore, even though it's referring to a pay method, which does technically exist, you still can't do that. So you would actually get a runtime error. It will compile, and it will run, but it will crash with a big red crap at the bottom because you can't do that. And that's what really throws people off with polymorphism. Let's take this example one step farther. So let's say that I have, let's say that I have a, let's do credit C equals new let's do a new platinum. So we've established a credit object that is a platinum. Now if I say platinum, and let's add another one. We'll call this gold. All right, so I'm going to say platinum P equals C. So remember, it basically automatically casts it to a platinum. Is this valid? Well, okay, let's dissect it a little bit. So we created a credit object. The compiler knows it's a credit object, and it knows that it must have credit properties. And we created an actual object called type platinum, and then told credit to point to platinum. Okay, great. Well, a platinum is a credit, so that's legal. Now I'm downcasting C to platinum. Now, downcasting is what caused the previous problem, right? Because a check is not a cache. But the compiler didn't know that it was a cache. It knew it was a payment. Well, in the same sense, the compiler doesn't know that this is a platinum. It just knows that it's a credit. But I'm casting it to a platinum. So by the same laws as before, it will not have a compiler error because it knows that, well, technically a platinum is a credit, so I think this is okay, I'm going to allow it. And because it actually is a platinum, this is totally fine. And when you run your code, it'll execute fine and there's no problems whatsoever. Is this bad practice? No. Is it a problem? No. Is it perfectly awesome? Yeah. But it's confusing, right? So why is this special and not a problem when it was a problem before? Well, it's simply because of the relationship. So what's the lesson you take away from this? Never trust the compiler 100% of the time, at least. It's pretty good about catching certain things, but when you downcast, you need to be very, very careful. If you're casting anything down the list, the compiler will almost always allow that because it doesn't know. But since it doesn't know, it can't affirmatively say that it's not valid, so it wants to trust you. And that may or may not be the best idea, but that's what it does. It's going to trust you and it's going to say, all right, dude, I will believe you that this is somehow a platinum object. And maybe it is and maybe it isn't, but it's going to allow you to execute the code. And it just so happens in this example that it is a platinum, so everything's hunky-dory and we have no problems. But instead of platinum, let's say I wrote gold. And just for ease of understanding, let's call this G. Gold equals C. So the compiler will automatically cast it to a gold. So this is like saying gold in parentheses C. So it's going to try to cast a platinum to a gold. Well, that's not legal, but because it's still a type credit, you're not going to get a compiler error because for all the compiler knows, this credit could be a gold. Just like before, it could have been a platinum. It just so happens it was. But in this case, this line actually is legit. But it's this line, gold G equals C, that is not. But the compiler won't know. So when you actually run this, then you're going to get what we call a class cast exception. Just like before, when I had a payment P equals new cash and then check C equals P. It would cause a class cast exception, which is obviously a runtime error and causes your program to crash. So casting down, be careful. That's what you need to take away from this. Casting up is fine. Casting up is great because casting up is a compiler checked type thing. If I said, let's do gold G equals new gold, and then let's do payment P equals G. Great, awesome. We've casted our gold object up. We casted it up to a payment, and that's perfectly fine because anything up is, or I should say, anything on the bottom is a whatever is above it. That's the is a relationship we were talking about. So a gold is a credit, is a charge, is a payment. So I could have payment P equals G here. I could have charge C2. I could have credit C2, or I could have gold G2, or whatever whatever names I wanted to call them. But the point is, if I put anything here besides something above it, then you want to be careful. Above it is fine, but below it is going to cause a problem, and sideways is always going to cause a problem. If I wrote, platinum P equals G, then we're going to get a class cast exception because a platinum is not a gold, and a gold is not a platinum, just like a charge is not a check, and so forth and so on. So, main points. Compiler knows what it can do. Execution actually determines what it will do, runtime. Sideways relationships are incompatible with each other. You can't create a cash equals new check. Only above relationships are totally safe. Payment P equals new cash, check, or charge, because cash, check, and charge are payments. And anything below it, casting below it, can be problematic if your object is not that. So I could cast a check, I could try to cast a check to a platinum if it was a type payment. The compiler knows that, well, a payment could be a charge and it could be a credit and therefore it could be a platinum. So I guess I'll allow this because all it knows is that, well, a check is a payment and a platinum is a payment, and it says it's a payment, so I will trust the dude that's writing this stuff and let it execute. But when it actually executes, then it's going to crap out and cause you some runtime errors. What else? I'm trying to think of other important details I haven't touched on. There's plenty more examples, and there will be a code example of this with more details. But this is the main stuff you have to take away. What causes class cast exceptions or runtime errors, what causes compiler errors, and what will actually behave properly. So hopefully you understand the concepts of casting and how casting up differs from casting down, and what the is-a relationship is. Other than that, I would make sure that you memorize this property, this concept, this can do, will do. That will help you understand what's actually going to happen. And the last piece of advice I could possibly give you is, well, first of all, a little sympathy. This is confusing. Yeah, I totally understand that. It's confusing to me when I first saw it. It's confusing in fact, I gave a review session once completely incorrectly because I didn't understand, or I'd forgotten one of the small details. I hadn't touched on it in a couple months, and Steve Couch showed up to watch me get red-faced in front of a room full of students because I didn't know what I was talking about. So it is totally understandable to be a little overwhelmed with this stuff, but the important thing is you learn these relationships, learn this can-do, will-do relationship, learn what it is a relationship is, and learn how the castings go, because at least if you're taking the kind of classes that I'm taking, if you're an Iowa State student like myself, you're going to be asked these things on tests, I guarantee it. And in any sense, you need to know it when it comes to understanding polymorphism and understanding these object-oriented properties and concepts, just for your career and for your future, for your ability to be a good programmer. So good luck. That's all I have for this one, so I'll see you guys next time.